Alright guys, the first video in section 7.1 here is going to introduce you to the graph of polynomial functions. So we've learned already about polynomial functions, the description of them, we've done operations with polynomial functions, and now we get into graphing polynomials. And this first section, 7.1, is really just planting a seed of how we're going to graph polynomial functions more in depth when we get to section 7.3. Okay? So as you know, polynomial functions are variables to exponents. In this case, we have a variable raised to the third power. But we're going to work with it as an example here. We would call this a cubic function because that's x cubed, x to the third power. Okay? Verbally, use words to describe the equation above. F of x is equal to a number cubed. Okay. When we get to our second page of this notes video, we're going to talk about the shifts that could occur, just like shifts that we've worked on for a number of different units, both lefts and rights, ups and downs. We'll get to that here in our next page of notes. The easiest way to graph any function, at least if we don't know the shape of the graph, is to just create a table of values. Okay? So we're going to create a quick table of values, some easy numbers to plug in, and in this case would make sense for a cubic function. We're going to plug in 0 for x, 0 to the third is 0. We can plug in a -1 and a -2, we can plug in a 1 and a 2, these numbers make a lot of sense for us. So if I plug in a -1, so -1 to the third power, -1 times -1 times -1, still -1. -2 to the third power, -2 times -2 is 4, 4 times -2, -8, and then we would do similar things here with 1 to the third and 2 to the third. Anytime you don't know what a graph looks like, creating a table of values and then sketching the graph would be really a good thing to do. So let's put these points on the graph and see how these would look graphically. Okay, so we'll put our 0, 0 point on the graph, our -1, -1, our 1, 1. I know the graph doesn't go up here, but if we went to 2, we'd be up here near the point 2, 8, and down here at the point -2, -8. Okay? And the way this graph looks, and this is something that over the course of some time, in x cubed being a function that we look at quite frequently in math, is something that we want to know that shape of. Almost looks like kind of a snake, if you will, a vertical, kind of curved a graph right here. Okay, so this is the parent function of x to the third. This is how every x to the third graph looks, something like this. And then again, when I said on the next page, we'll get into how this might look with transformations, both lefts and rights and ups and downs. Okay. One of the main points, however, of lesson 7.1 is for us to start talking about end behavior. Okay. In end behavior, and let me slide up the paper so we can see both the graph and this row of our table. End behavior deals with what's happening at the ends of our graph, okay? On the right side of the graph and the left side of the graph, okay? So, if we go back up here to our graph, the end behavior, we're not necessarily worried about what points the graph is going through in the middle of the graph. What we're worried about is what is happening here at the ends of the graph. Okay? What I've highlighted there in blue and green. Okay? So the things that we say about this, like as the graph is going left, this graph is going down. On the right side of the graph is going up. Okay? And those are important. That's maybe the most important part of our 7.1 notes videos. Okay? So let's go down here and it says the end behavior, the left and right side of this parent function end in different directions. The characteristic is known as the function's end behavior. Okay? So again, without writing what's happening in the middle or the specific points that this is going through, we're going to represent visually what's happening as the graph goes right and goes left, or the right side and the left side of the graph. And just looking above here, the right side of the graph goes up, and the left side of the graph goes down. Okay? And I've used different colors here because they're going to link to one of these two things. Okay, so this is our visual representation of what's happening on the right and left side of this graph up here, our x to the third function. Algebraically, what we can say is that as x goes to, this arrow means as x approaches or x goes to negative infinity. Well, negative numbers on the x-axis would be to the left. So really what this is saying is x goes to the left. I'm going to highlight this kind of in blue here. That's the blue part. As x goes to the left, y, that's how, the up and down of a graph, y is going all the way down low also to negative infinity. Right? And this means that it would be going down. And then we can also say as x approaches infinity. Well, positive infinity, positive numbers are to the right on a graph. So this is representing this part of our end behavior as highlighted in green. And really what this means is x approaches infinity, or as it goes all the way to the right, y will approach. Well, which way is it going? It's going all the way up to positive infinity. Again, as x goes to the right, y goes up. Okay? And that's really what we're looking for in terms of our end behavior. So now let's take a look at a transformed cubic function using our shifts and things that we've learned and used in multiple different units and sections here. As you can see, we still have a cubic function here. So it is going to look like the graph of the one we graphed just a second ago. But we do have some shifts. A -2 on the interior of a function, that's going to mean that we're shifting right 2. A +1 on the outside, that means we're going to shift it up 1. It says in words describe that. Well, we just did. Right 2 and up 1 from the graph or the parent function we did on the other page. Okay? So if we're going to do this numerically, it says choose values before and after the shifted x value. Well, our shifted x value, if we were at 0, 0, we're going to the right 2. Our first x value we want to consider is probably +2. Okay? If I plug in a 2 here, 2 minus 2 is 0. 0 to the third is 0. Plus 1 is 1. Okay? That was where that 0, 0 point was. Okay? We can do the same thing with the number 3, the number 1, the number 4. Okay? When we plug in a 3, 3 minus 2 is 1. 1 to the third power is 1. 1 plus 1 is 2. Okay? And then we can do this here. All right? We can trust that that table is correct. And we're going to see that when we shift these points. So what points should we want to shift here? Well, the points that fit on this graph that we graphed in the previous one were the points -1, -1, 0, 0, and 1, 1. We also understand the way the graph is shaped, how it's going to look. It's going to look like the other graph because it's the same parent function. Okay? So let's graph this here in purple. Okay? We're going to take each one of these points and shift them right 2 and up 1. So I take -1, -1, right 2, up 1. Take the 0, 0, right 2, up 1. Take the 1, 1 point, right 2, up 1. Okay. We should know this function's shape. We should know its end behavior because it should be the same end behavior as we had in the previous one. On the left side of the graph, it's going down. On the right side of the graph, it's going up. And again, let's graph these in kind of that proper color. So in the middle of the graph, we'll be looking like this. And we also know the ends of the graph, its end behavior. The right side of the graph should be going up. The left side of the graph should be going down, kind of to match up that end behavior. Remember, when we graph these polynomial functions, and like I said, we'll do it in more depth in 7.3, we kind of think separately about what points are happening in the middle of the graph that our graph will be going through, and then what's happening on the ends of our graph, the right side and the left side. So let's scroll down to our bottom column here. Okay, indicate the end behavior. Well, let's take a look at our graph. All right, down and up, left side down, right side up. Pretty simple. So the visual representation of our end behavior just kind of matching the colors that we used in the top graph. Left side down. So verbally, we could say that the left side is going down. And we could say that the right side is going up. Matching up the colors with what we mean by left side and right side of the graph. Same thing here, as x is approaching negative infinity, negative numbers are to the left. This is the left side of the graph. Our y values would be going down, also to negative infinity. As x approaches positive infinity, that would be all the numbers to the right. So as x goes to the right, we're looking here. We know that our y values are going up to positive infinity. Okay? So really three different ways that we can state an end behavior. We can state it visually, we can state it with words, and we can state it algebraically using x's and y's and whether they're going to negative infinity or positive infinity. And that'll wrap up this notes video.